In this video, we present experimental results to demonstrate the features of the proposed task allocation and execution method. The setup of the first experiment is as follows. 6 agents composed of 3 ground robots and 3 simulated quadcopters are to be assigned to and execute 6 go-to-goal tasks. To simulate unknown environmental variations, we introduce a no-fly zone for the quadcopters and a river that cannot be traversed by the ground robots. Note that these limitations are unknown to the robots beforehand. This ground robot is assigned to a task on the other side of the river that it cannot traverse. The task allocation learns that the robot is not effective at executing the task and reassigns it. Here, the ground robot is successfully reassigned. Note that a quadcopter is assigned to the task that was previously assigned to the ground robot. Similarly, the leftmost drone is unable to reach the task inside the no-fly zone. Again, the allocation is adaptively changed to reflect this. This way, all the tasks get achieved successfully. In this experiment, we considered the case where environmental variations are temporary to evaluate the specialized results from the task execution and allocation framework. The setup is as follows. 2 simulated quadcopters and 2 ground robots are to be allocated to and execute 4 go-to-goal tasks. As opposed to the last experiment, here, each task has an associated environmental restriction. An orange circle indicates that the area around the task is a no-fly zone for the quadcopters. A blue circle indicates that the task cannot be reached by the ground robots. Finally, no circle means that there is no restriction. Again, it is important to note that all the robots are not aware of these restrictions beforehand. The quadcopter is unable to reach the task due to the no-fly zone. As before, the allocation adapts to reflect this. All the tasks are successfully executed. To simulate the temporary aspect of the environmental changes desired for this experiment, we change the restriction associated to each task. Note how the color of the circles change. Again, the 2 middle robots are reassigned successfully to the tasks. Note that the quadcopter in the middle regained its capacity for a task it could not previously execute, thus demonstrating the ability of the proposed task allocation algorithm at adapting to environmental variations.